Okay, congruent arcs in chords. A lot of words, but it's okay. So two chords are congruent if and only if the corresponding arcs are congruent. So in this case, chord AB would equal chord CD if and only if the arc AB is equal to the arc CD, based on the picture to the left. Also, two chords are congruent if and only if they are equidistant and just how it looks, equidistant is equal distance from the center. So again, chord AB would equal chord CD if and only if EF, that little line that connects it to the center, is equal to the other little line that connects to the center, which is EG. Okay. And last but not least, if a diameter or a radius is perpendicular to a chord, then it bisects. Remember, bisects is cuts in half. The chord and its arc. So if EH is perpendicular with AB, then AF equals FB, and measure of arc AH would equal the measure of arc HB. All the things. But again, a lot of equal to. So odds are what you're doing in this section is setting things equal to each other. For example, in number 1, the two marked chords are right here, and the two labeled arcs are with the chords. So when that happens, set everything equal to each other. 7x plus 24 equals 115. And it's just algebra, right? We subtract 24. 7x without 1. 7x equals 91. Divide. X equals 13. Same goes for in number 2. The marked arcs match up with the labeled chords. When that happens, set them equal to each other. Add 2 to both sides. Divide both sides by 18 in this case, and you will get x equals 3. In number 3, we have those marked arcs. And we have the labeled chords. So go ahead and set them equal to each other. Subtract 4x from both sides. And 34. Divide by 5, x equals 7. Notice how they, in this case, it now says to solve, so to plug it back in. So instead of 4x, 4 times 7 plus 1, PEMDAS, 28 plus 1 equals 29. Okay. Again, arcs are labeled, chords are marked, so we can set them equal to each other. X should equal 13. And again, they say find RS. There's RS. So we're going to plug in 13 in for X. And according to PEMDAS, that should get me 71. Now notice number 5. Those are the marked chords. So the matching arcs are the ones that go off of it, which in this case, what's been labeled are not matches, okay? So we can't just set things equal to each other yet. But we can fill in the last section of the circle, that top green section, because of the matching chords, I know that, or the matching chords, we have matching arcs. So I know this is also 6x minus 20. At this point now, I know that all parts of my circle have been labeled. And we should know that by now a circle is 360. So you can add the two 6x minus 20s and the 76 and set it equal to 360. Right? We would get, what is that, 12x, 76, minus 20 is 56, minus 20 is 36, is equal to 360. Subtract the 36, subtract the 36. 12x equals 324. Divided both by 12, and x should equal 27. Okay, so that one's a little bit different. And then number 6. Since nothing's been labeled, I do recommend we try to label our picture. So this MP right here, I'm going to draw an arrow to it, is 5x minus 34. And then we use a different color. Then they say PN is 2x minus 4. And it says two little lines, so that's from the last bullet point from the very top. So we're back to taking the two things and setting them equal to each other. So x should be 10. But again, they say find MP. So instead of 5x, we're going to do 5, 10, and then 34. So 50 minus 34 should get us 16. Okay. I'll zoom out in case you need to pause, get anything down. At this point, that is the conclusion of this set of notes. For the most part on this one, you're just setting things equal to each other, except for number 5, that one's a little bit different. And then solving for x, and then just be wary if they're asking you to plug back in.